Hello everyone, this is Mr. McMillan and I'm here with an instructional video. This time we're going to be working out some additional examples on sector area and arc length to prepare you for the worksheet that is posted today. So let's look at number one. It says to find the length of the arc in bold. So it's talking about this arc here, this major arc here. Now it wants us to find the arc length. Now remember, your arc length is given to you by the formula. We talked about this formula before. Theta over 360, and then in parentheses, you're going to multiply it by 2 pi r. So again, you need your theta, which is your angle that's associated with the arc, as well as your radius. So in number one, we need our theta and we need our radius. Now you guys are probably not used to having angles that are larger than 180 degrees, but in circles, you can have an angle that's all the way up to 360 degrees. So in this case, our theta that's associated with the arc, we can see that it goes around 300 degrees. So we have theta is 300 degrees. And our radius in our problem is 14. And now we just plug it into the formula. So we put theta over 360, so 300 over 360. And then in parentheses, 2 pi, and then times r, which is 14. And now we just simplify this. So we're going to do it both ways. We're going to do exact and approximate for these problems, just to show you how to do both of them. So if we go to Desmos, So if we go to Desmos, we're going to do the exact one first and then do our approximate. So we type in 300 over 360 times, and then we put our 2. Now, since we're doing an exact one first, we don't type our pi in. Our pi is just going to be on the end of our answer or the end of our fraction or number here. So 2 times, and in this case, 14. So that gives us 23.3 repeating as our decimal. And so we want to make that a simple or fraction in simplest form. So we click that and we get 70 over 3 as our fraction, which, 70 over 3 is our fraction. So 70 over 3 pi would be our exact arc length. Now what we're going to do the same thing, but we're going to do it exact. So, approximate. So 300 over 360 times, and then we're just going to type in 2 pi and then times 14. And so that gives us an approximate arc length of 73.3. So some of these problems will ask for exact length, and some of them will ask for an approximate, and it'll tell you what to round it to. Now there is a pi button here, down here on the calculator. You just click that and it will add pi to it, or you can just type in pi for pi and it will give you the symbol as well. All right, so let's look at number 2, and you can go ahead and try number 2 if you like, and then go ahead and see if you get the correct answer. So number 2 says find the length of the arc in bold. So again, we're looking for arc length. So we need to know 2 things. First is our theta, and the other is our radius. So theta is the angle associated with the arc, and we can see here that that would be 135. And our radius is equal to 11. So now we just plug it into our formula. Our formula is theta over 360 times 2 pi r. So we take 135 over 360, And then in parentheses, we have 2 pi times 11. And now we just go to Desmos, and we're going to get our exact answer and our approximate answer. So we're going to do our exact answer, 135 over 360 times 2 times 11. And that gives us 8.25 as our decimal, which turns into 33 over 4. And then at the end, we're going to tack on the pi. Okay. Now, if we wanted to do the exact or the approximate, excuse me, we would just multiply by 2 pi times 11. And so we get that our approximate is 25.9. Okay. So 33 over 4 pi, which is approximately 25.9. All right, number 3, find the area of the indicated sector. So this time we're not going to be finding the arc length, we're going to be finding the sector area. And as we talked about yesterday, the sector area formula starts out exactly the same as the arc length. So we have theta over 360. But what we do next is we use the area formula instead of circumference like we do for arc length. So in the parentheses, we're going to put pi r squared. But past that, the process is much the same. So you need to make sure you read the question and determine whether it wants you to find the arc length or the sector area. So on number 3, find the area of the indicated sector. So in here, you see that your theta is 240 degrees and your radius is 7. So now we plug that into our formula. So theta over 360 is 240 over 360. And then in parentheses, we have pi times r squared, which is 7 squared. So now we go into Desmos and we find our exact and approximate ones. So our exact, 240 over 360 times 7 squared gives us 32.6 repeating, which as a fraction is 98 over 3. And then don't forget to tack on the pi. And that is approximately equal to, I'm just going to copy and paste this to make it quicker. That is approximately equal to 102.6. Okay. So what I want you to do, I want you to try number 4. I want you to find the area of the indicated sector. So pause the video, try to find it, and then check back with your answer. So let's look at number 4. Number 4, our theta is equal to 150 degrees, and our radius is 17. So we're looking for the sector area. So we're going to do 150 over 360. And then in the parentheses, we have pi times r squared, which is 17 squared. Now you are going to get a rather large fraction for this if you do it the approximate or the exact way. So you get 150 over 360 times 17 squared. And so that gives you 1445 over 12. Don't forget your pi at the back end because we're doing an exact answer. And if we do this approximately, we get 150 over 360 times pi 17 squared. And we get that our approximate area is 378.3. Okay. All right, number 5. Number 5 is a little bit of a word problem. So it says Robert divides a pizza into 12 equal pieces. This is supposed to say pizza, but typos happen. If it had a diameter of 22 inches, what is the approximate area of each slice? Now this is a bit different from the other ones. We're still going to be finding our radius because we need that. So in this problem, it gives us that the diameter is 22 inches. So if the diameter is 22 inches, how much would the radius be? Well, the radius is half the length of the diameter. So you take 22 over 2, which gives you 11. Now where this differs in is that we don't have to find a theta. And the reason for that is because we'll already know what the fraction is that should go in front. So it wants to know the approximate area of each slice. So the approximate area of each slice would be the approximate area of one slice. Well, it says that he cuts it into 12 equal pieces. So you have one that you want to find over the whole, which is 12 pieces that he cut it into, and then you're looking for the area. So you do pi times r squared, which is 11 squared. So the reason we do 1 over 12 again is because you do the part. So you're looking for the area of each slice, which is one slice, and then divided by the total number of pieces, which is 12, and then you multiply it by the area. Now this one wants the approximate area, so all we're going to do is plug this all into the calculator. So 1 over 12 times pi times 11 squared. And you get that your area is approximately 31.68 inches squared. Okay. It didn't tell us what to round to, so I just rounded it to the nearest hundredth. All right, number 6. Number 6 says circle K contains a central angle KLM with measure of 100 degrees and a diameter of 16 meters. What is the area of sector MLK? So in this one, we're going to draw our picture. Okay, and it says that we have a central angle with a measure of 100 degrees and a diameter of 16 meters. Well, if our diameter is 16, remember we need to find our radius, not our diameter. So the radius would be 16 over 2, which is equal to 8. Now it wants to know the area of sector MLK. So we're looking for the sector area. So we do theta over 360. Well, our central angle is 100 over 360, and then times pi r squared. So r is 8, so you're going to put 8 squared there. And then you're going to determine your area. Now you can do it exact or approximate. We'll do both. So the exact the exact would be 160 over 9 pi, and the approximate, you would multiply this by pi, and you get that it would be 55.85. Okay, so you need to know how to find both of the exact and the approximate. All right, we're coming up at the end. There's supposed to be a B here. So just letting you know. So it says to find the length of arc ARB in circle C. Now if we look here, it's looking for the arc length of this arc. Now we have to start at A, and then we go to R, and then we go to B. Now notice that ARB is a major arc. which means that its degree measure is larger than 180. Well, if we look at the theta that we have here, is that angle corresponding to ARB, or is it corresponding to just AB? And the answer is that it's only corresponding to AB. We know this is a major arc, so it has to be greater than 180 degrees. So how do we determine what theta deals with ARB? Well, we know that this is a circle, and the degree measure of a circle is 360 degrees. Since it's 360 degrees, we can find the other angle by taking, or our actual theta by taking 360 minus 162, which is 198 degrees. And then we use our radius, r equals 12, and then plug it into our formula. We're finding the arc length, so we need to do theta over 360, so 198 over 360, times, and since it's arc length, we don't do pi r squared, we do 2 pi r. So 2 pi times 12. Then if we go into Desmos, 198 over 360 times 2 times 12 gives us 66 over 5 pi as our exact answer. And if we do approximate, we multiply that fraction by pi and we get 41.47. Okay. So make sure you pay attention to which arc that it wants you to find. If it wants you to find the major arc and you don't have an angle for it already, then you need to find it. And then our last one we're covering in this video, number 8, the circumference of circle X is 320 pi. What is the exact length of ZWY? So if you look at arc ZWY, you can see that arc ZWY would be a minor arc. So that theta we have is already what we're going to use. Now you'll notice here that there's no radius mentioned in the problem or labeled in the diagram. So let's see what we're going to do about that. We're still looking for the length of the arc, so we're going to take theta and put it over 360. Now, normally when you find the arc length, you do 2 pi r. Well, 2 pi r is the formula for the circumference of a circle. That's the circumference. Okay? Well, 2 pi r goes all the way in here. So if we already know our circumference, we can just plug it into our formula without needing to know r. So our circumference is 320 pi. So we just plug that in there. And then we just find the exact length. And we want to find the exact length because that's the one it wants in this problem. So we take 105 divided by 360 times 320, and we get our fraction to be 280 over 3, and don't forget the pi. Okay. And that's going to do it for this video, guys. I do hope that this video has helped. You are going to, do have a worksheet there, as well as some Excels to complete and all that stuff. But if you look here on this worksheet, I'm just going to show you. At the top, it has places for you to write your equations in for arc length. And then you need to make sure that you read the questions carefully to find if it wants you to determine sector area or arc length, as well as whether you have a diameter in your problem or a radius. Okay. Number 6 and 7 are one where you're splitting the things evenly. So make sure you're aware of how to do that. that was number 5. Pay close attention to number 7 because it's a little bit tricky the way it's worded. And then for these things, when it asks for the arc, make sure your arc is a minor or major arc and see if your theta matches up with what you need. If it doesn't, then you need to find the missing angle. The rest are types of questions you would more likely see on a quiz or a test, the way they're worded, as well as an in-the-course test. So they're wordier, they have more things, they look a bit more complex, but in reality, it's the exact same stuff over again, okay? So that's gonna do it for this video, guys. I hope that this video helped. If you do have any questions, please feel free to email me. And if you need to set up a Zoom with me, you know, feel free to do so. Thanks, guys, and I will see you in the next video.